Ramir wasn't here. Everybody else was here yesterday, right? Eunice wasn't here yesterday, but Mr. Newcomer was here yesterday. How many of you guys are pretty convinced you can tell me what the second fundamental theorem of calculus is without looking at the poster, or at least write it down? One person, maybe two people, maybe three. Maybe like have a quick download with somebody near you. Second fundamental theorem of calculus, what is it? Tell them. Don't look at the poster.
I just didn't finish it.
Alright, let's close out in 3, 2, 1. Jennifer Flores, tell me second fundamental theorem of calculus.
Can I write it?
Yes. Sure, come on. You got it. Okay, second fundamental theorem of calculus. We've got the ddx, which means derivative. We've got the squiggle, which means the integral. We're going from a to v. A to x, maybe?
Thank you. No, just replace it. No. Yeah.
Oh, that's where we replace the variables, right?
There we go. F of t dt, and that's going to be equal to f of x. Well done. Thank you very much. Thunderous applause.
Oh, I'm doing it.
Second fundamental theorem. Ramir, Eunice, honestly, this is all that it is. We're finding the, you guys know what this is? Derivative. You guys know what this is? Integral. We got a function. This guy down here that looks like a 9 is really a, and this is a constant. Then you've got this guy up here, which is your new variable. You've got your original function, f of t, original function, and then your final answer is original function with the new variable. Wow, handwriting's horrible there. Okay, but seriously, if you see derivative of the integral of a function from a constant to a variable, we get the original function back, new variable. We're okay? This is meant to be like 3 seconds. But you have to check all the parts. Think about that multiple choice question yesterday where there was no derivative and you guys were all like, I'm going to use the second fundamental theorem of calculus anyway. And you all get it wrong. The second fundamental theorem of calculus, if you see derivative of the integral of a function from a constant to a variable, you get the original function back. Great. Then there's the extended version, which looks a little something like this. The derivative of the integral of a function from a constant to a new function, f of t dt. Tell somebody near you, what's that final answer going to be? Derivative, integral, function from a constant to a new function. What's the final answer?
F of g times derivative of t.
Juanco, what's the final answer going to be?
F of g of x
F of g of x.
times the derivative of g times x.
Careful, not times the derivative of g prime, just times g prime. It looks like the chain rule. It's not the chain rule, Abraham. What's different about this from the chain rule?
You're not getting the baby is not prime. I mean,
Mama.
Right, you don't take the derivative of the mama. It looks a lot like chain rule, but not chain rule. Big picture, everybody kind of okay?
Yes.
It's the new tool in the toolbox. So here's what I want to do. I want to show you guys where we're going to go with this. Here, I'll take it. You look like you were on Tumblr or Timbler or Twitter or whatever it is. Okay, 30 minutes. Here's what I want to do. Careful, Edgar. You look like you're getting a little too hyped up. Calm down. We're all good. Okay, 30 minutes. We're going to do a journal entry. It has been a while since the land of the journal entries. I care greatly about notation. Now, when I wrote this, I deliberately wrote this to review some big ideas. Some of the big ideas that are coming my way, coming your way. Relative maximum. You guys show me a relative max? It's been a while. Relative max, what does that look like? What does that look like? Relative max, relative max. I keep seeing this thing. Don't like that. Or one more. Yay, I see what you did there. Right? It could be the smooth kind or it could be this kind. But how do you prove it? How do you prove a relative max, David?
You're changing from increasing to decreasing.
Now, I like it, don't love it, because it sounded like you said the word it, and it's hard to see the word it. We don't use the word it. What's changing?
The function is changing.
The function is changing from increasing to decreasing. What's the other way to prove it? The other way to prove it. You have a relative max. The function changes increasing to decreasing. What's the other way, Ramir?
The derivative is equal to 0.
No. 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 And the fact that no one else knows really scares the heck out of me. If the original function changes from increasing to decreasing, something else happens. Something else happens. No, Amy, what happens?
The derivative changes from positive to negative?
The derivative changes from positive to negative. That doesn't mean derivatives equal to 0. The derivative changes from positive to negative. Now, another thing that we used to talk about all the time, points of inflection. Points of inflection, 3 ways. 3 ways that you can decide if something has a point of inflection. I'll take any one of the 3. Point of inflection. Edgar.
The change from positive.
See, you said it, I stopped listening.
The function changes from positive to negative.
The function does not change from positive to negative at point of inflection. You might want to look this up in your binder. It's probably on a gold sheet somewhere. Salma found it faster than anybody else, except for possibly Rambir. Eunice, point of inflection. What do you do? What's the it though? See, I don't know the it. If a function has a point of inflection. Point of inflection, Nora?
The function changes concavity.
F changes concavity. So, hey, there you go. So F has a POI means F changes concavity. That's one of 3 ways. You need to know all 3. F changes concavity, something else changes. Jennifer.
F prime changes from increasing to decreasing.
F prime makes a change from increasing to decreasing, or the changes from decreasing to increasing. That's another way. Abraham.
Is it F double prime?
F double prime, how does it change?
Positive.
Positive to negative, or negative to positive, right? Okay, good. These are some of the things. Okay, so let's take that and see where we can go. Take a minute, read this problem over, we'll be ready to talk in about a minute. Here comes the push. So excited. So excited. Read this really carefully, make sure you understand what's going on. Make sure you know what graph you're looking at. The graph of the function f shown above consists of a semicircle and 3 line segments. Let g be the function given by g is the definite integral from -3 to x of f of t dt. Last class they were really confused by why -3? Because when they wrote the problem, they just said let g of x be the definite integral from -3 to x of f of t dt. It was just a choice to make. Part A, find g of 0. Trust the instincts. What would you do when you see a problem like this on the trimester exam? What would you do? Just Rambir? Just Rambir and Nora? Trust your instincts here. Jasmine, what would you do?
I would put 0 in place of the T.
In place of what?
T and the.
Not T.
I said X.
You said X. It's my old man ears. Right? You want to think of it like a function. G of X is the integral from -3 to X of f of t dt. So G of 0 means go find the integral from -3 to 0 of f of t dt. And I'm sure that everybody knows exactly how to find that integral. How am I going to find the integral from -3 to 0 of f of t dt? Oh gosh. Oh Oh gosh, Adriana, how are you going to find that integral?
You find the area?
Definite integral meant way back in the day, and still now. Go find the area. Okay, go find the area.
Is this calculator?
You don't need a
It's
calculator.
calculator
This is the graph
inactive.
of f. Find the area from -3 to 0. Here's -3. Here's 0. Lots of options. And by lots, I mean at least 2. Okay, Mariah, you're seeing trapezoids? Did that work?
I prefer to, yeah.
Do you remember the area of trapezoid?
Actually, I'd
Edgar
rather
does.
do a triangle and the other thing because it's easier.
Okay, you could if you wanted to do triangle and the other thing. By other thing, we mean the rectangle.
Yeah, but it's.
Okay, but if you want to go with a trapezoid, and this is a trapezoid, Edgar, what's the formula?
1/2.
1/2
Base 1
base 1
plus base 2
plus base 2
times height.
times the height. Or triangle and the other thing.
Yeah.
Either way, when you work this out, if I'm going to use my trapezoid, I'm going to get 1/2, 2 plus 1 times 3, I think 9/2. Is everybody okay with 9/2?
Yes.
Another good answer, 4.5. 1 point. Perfect. Now let's pump things up a little bit. G prime of 0. G of 0 equals 9/2. I want to find G prime of 0. Have a strategy conversation with somebody near you. Don't tell me. What would you do?
You do
G prime of 0.
No, that'll be F. G of X equals. The first one. No, the second. That's -3.
Right. G prime of 0. It's a two-step operation here. First, find the derivative. Second, go plug in 0. So for all my folks that are picking up on this, first I have to find G prime of X, which means go find the derivative. Oh, go find the derivative of the integral from -3 to x of f of t dt, and everybody knows what that answer is. Derivative of the integral of a function from a constant to a variable, this is f. This is that second fundamental theorem of calculus that you missed yesterday, Robbie.
That's what I said.
Right? That's what it is. What I want G prime of 0. Well, what is G prime of 0? If G prime of x is f of x, then when I say go find G prime of 0, I just mean go find f of 0, and you're going to tell me f of 0 is?
1.
F of 0 is 1. Mariah, where'd you get that from? Right. Finally, I get to use the graph. This is the graph. Second point earned. All right, next part. G double prime of 0. Trust your instincts here. G double prime of 0. Trust the instincts or the antenna that Nora's pointing to. Right, G prime of x is equal to f of x, so that must mean if I take one more derivative, G double prime is the same thing as f prime. I need G double prime of 0. Well, that means go find f prime of 0. F prime of 0. What is f prime of 0? 9/2, not 9/2. What is f prime of 0? Gosh, what does that even mean?
Find the derivative of the point.
It means find the derivative. Another word for find the derivative?
The slope.
The slope, not inverse. Slope. What's the slope? Abraham, what you got for me? You think what?
-1/3.
So you're saying that the slope over here is -1?
-1/3.
-1/3. So it looks like maybe you're doing like, what's the slope from -3, 2 to 0, 1? I have a slight problem with that.
And it also-
There's a problem with finding the slope at this point.
So then we also say it's the slope from the same as for like from 0 to 2.
Right, what I hear Abraham saying is find the slope between -3, 2, and 0, 1, and that's gonna give you one answer. But if you find the slope from here to like this guy over here, or a point getting closer, you get a different answer, there's a problem. We have a special name for this point. It's been a while. Not the vertex, not a point of inflection. They're coming together in a really sharp kind of way.
Cusp point.
It's a cusp point. And so if this is a cusp point, you guys know exactly what the derivative is. Does not exist because of cusp point. That would get you third point. Is everybody mostly okay with part A? Well, I'm going to let you guys play around with this for a little bit. But here's the thing. Here's the thing I really want to point out. We started off with g of x, which is going to be this integral from -3 to x of f of t dt. I started asking you guys questions about g prime, but g prime, really we know g prime by another name. G prime is really f of x, and I have a graph of f. Then I asked you a question about g double prime, but really we looked at f prime. The rest of this problem is going to ask you questions about g. But when I say g, what you're really going to think is, when I say g, you're really going to have to think about this guy. And if I ask you something about g double prime,
F prime.
it's really an f prime kind of conversation. But the only thing you get to see, the only thing you get to interact with is f. Kind of okay? All right, so with that, with this like little key over here, let's put my little thought bubble around it. I want you guys to show me what you can do with B and C and D. I'm going to put 5 minutes on the clock. We'll talk in 5. B and C and D. Yep.
No.
You guys can work together.
Yeah, so G prime equals, yes.
No. The first one.
I'm just gonna focus on G prime is positive, and then just find
So just f of x.
so whenever f of x is positive.
Oh no, it makes sense here. If G prime, if this is positive,
I want to remind you about the importance of good notation.
G prime.
So Mariah, if G's increasing, what's the thing you know for sure?
F of x is positive.
You're right, but get me there. G's increasing. I bet that's not the first thought you had. If G's increasing,
That's what 2 is. Wait, 3.
first thought something like G prime is positive.
Is it?
But I don't see G prime anywhere. Right. So this means that F has to be positive.
Or yeah,
G's
or I was gonna do
increasing.
this.
That means the derivative is positive.
Wait,
Or that. That works.
can we just say whenever f of
These
x
are
is
like
positive?
Yeah.
Yeah, I want to make it really clear that you're looking at G and you're saying, here's what I know about G prime, but G prime and F are the same thing.
So
No. Yeah, I figured that too.
-4 to.
So here you're saying -4 to 3. Because this guy over here is positive, there's one thing I don't like. For all the folks that are on board with part B being from -4 to 3, there's something I don't like, and it's wicked picky. Super picky. We definitely have to have parentheses conversation. David, what's the other thing?
It's the domain is from -3 to x, and so -4 is also.
Nope. It says for what values of x is G increasing? G's increasing, G prime's positive. If G prime's positive, that's the same thing as saying F is positive. I heard from Mariah and other friends from -4 to 3. and there's something, I'm being super picky here. Jonathan, what am I being super picky about? What's happening at x equals 1? At x equals 1, the function is not positive. The function's equal to 0. So the best answer isn't negative 4 to 3.
Negative 4 to
Negative
1.
4 to 1.
Negative 4 to 1.
Two.
Parentheses, because I want strictly positive. Me. And then from 1 to 3. I've got to go all the way from negative 4 to 3, but don't include positive 1. Okay, keep going. How'd I make the jump this G half? So G is increasing. If any function is increasing, but if I say G prime for this problem with this function in front of me, G prime is
is positive, the derivative is
Negative 2 to 3.
I see what you did there.
Isn't that
Okay, because the mathematics
one of the F values?
specifically, it was the second fundamental
Is it when
theorem of
it's
calculus
decreasing
that
or
relates
changing
to
to positive?
G
It's
prime.
from positive to negative. So then it would be
So when I ask you
from
about
2 to
G
4.
prime, I'm really asking about
What?
okay?
From 2 to 4. I think it's just like X equals. I don't think it's negative.
yellow sheet, I have it.
Oh wait. So X equals 3. So negative 5. Yeah, so X equals 3.
G prime is,
Ooh, negative 5 what?
G prime is to the
To
prime.
go from decreasing to decreasing.
Right, so the way I wrote it, G is increasing means G prime is
So F prime
positive,
should be changed.
but G prime is the same thing as F.
Wait, which one? Negative to 1? No. X equals 3.
Keep going, B, C, and D.
No, I think you're right. No, it's X equals 3. It's all the values is X.
G
So
has a
it's
relative
an
max.
F2.
Maximum positive to negative.
Not positive.
Yeah, I don't know how to believe myself now.
The second derivative.
Yeah.
So if the function I'm asking about is
Is
a
that the
relative
answer?
max,
It's X equals 3,
this
right?
or the point
I think you're right.
then that
No, I
function
think
changes.
this is right.
You think it's right?
Yeah, I'm saying you're right, and I think I'm right.
Changes.
Find all values of X in the open interval, blah, blah, blah.
So that's
Relative
G
maximum
has
is
a relative
important,
max,
it's
G
not a.
prime
So,
changes
yeah.
from positive to negative.
Jesus! Find all the values of X in the open interval that has a point of inflection. The point of inflection. Right there. Change your, yeah. There.
Not G prime. G prime makes a change. It's not that. It's not that.
Oh, you're right.
So where?
Because G prime equals F.
I'm writing that down
F, right?
first.
So whenever this is negative, then G prime.
If
I'm just writing all
G is a
that.
relative max, then that's careful.
I think it's just easier to look at
G has a relative max.
It's increasing to decreasing.
Changes, increases.
That means that has to go from positive. G prime has to be positive to negative.
So what is it that changes to positive?
So here, at these two, at this point, x equals 3.
Prime.
Because look, if
I think it's still X equals negative 3, X equals negative 2.
So where
X
does
equals
that prime
negative
doesn't match.
2. That's what I think.
So G prime must be going from positive
Negative 3
to
and 2.
negative.
Negative 4 and 3.
If
And
this
1? Yeah, I was looking at 1. Wait, 1? Yeah, 1, 2, right?
So then f of x has to go from positive to negative. Only go from positive to negative at x equals 3.
All right, I want to close out this in just a little bit. If G has a relative max, I'm seeing a whole lot of confusion happening. If G is a relative max, then G changes from increasing to decreasing. G would change from increasing to decreasing, which means to me that G prime, which we also just call F, makes a change from positive to negative. And where does G prime change from positive to negative? It happens only at
X equals
3.
-3. Wait.
How many of you guys honestly had 3? Alright, let's move on to part D. Okay, part D. Same graph at the top, I just recreated it for ease. Alright, D. For all values of x in the open interval -5 to 4, at which the graph of G has a point of inflection. Take a minute, do this one completely on your own. Completely on your own, Rambir. G has a POI. What does that mean? 1 minute, we'll talk in a bit. If you already did it, try part E.
You just blurted out.
You're talking about the wrong function.
Who is she? G double prime?
You've got to get the function names right here. See a whole lot more writing. Partially right, but not fully right. I'm talking about your whole answer. Okay, I have not seen the full correct answer yet. If G has a point of inflection, that means that G prime, which equals F, right? G has a POI, something special is happening with G prime. Juan, what's the special thing that happens with G prime?
It changes from increasing to decreasing or decreasing to increasing.
Right, or the changes from decreasing to increasing. I have to see that you're considering both cases, and I need to see that you've got your justification. So where does G prime change from increasing to decreasing? At x equals -3.
X equals 0.
And at x equals 0?
X equals 1.
At x equals 1, oh my god.
No, 2.
Where is G prime changing from increasing to decreasing?
Oh.
2.
At x equals -3, there's that change.
Oh.
And
X equals 2.
at x equals 2.
Wait, isn't that a 1 also?
Okay, but hold on.
No, that's
I'm
from
saying
decreasing
where
to
does
increasing.
G prime change from increasing to decreasing? The change is specific here. And then where does G prime change from decreasing to increasing? That's why you guys keep telling me
X equals 1.
1. I'm handling one of the changes here, the other change down here. Alright, we're going to do one more part together, and I think we're going to close out with this journal. E, find the absolute minimum of G on that closed interval -5, 4. Justify your answer. Some of you already shuddered a little bit. Good. G has an absolute minimum. Absolute minimum is not the same thing as relative minimum. It never has been. It never will be. Absolute minimum always requires more work. A lot more work. And what we used to do with absolute minimums and absolute maximums, and every time I do this, I want to thank Miss Blakely at East End. She always has her kids make a table. And over here, she's like, okay, what are the x values that I'm considering? And then over here, what's the value of the function at that point? And the question is, where might I have a minimum? Where might I have an absolute minimum? I'm going to wait until there's like 8 hands. I see 1, I see 2, I see 3, I see 4, I see 5. Waiting for like 3 more. I've got 6. Where might G have an absolute minimum? Jasmine, where might G have an absolute minimum?
At x equals -4.
At x equals -4?
Right.
I agree with you. We'll come back to that in a little bit. I didn't think you'd start there. I didn't think you'd start there. Eunice?
Negative 5.
-5? Why are you considering -5?
Because that's one of your inputs.
It's an endpoint. They're always going to give you an interval. Here's your endpoint. So obviously, if we're going to consider -5, we're going to have to consider +4. These are both here because of endpoints. Jasmine, tell me why -4. You're 100% right.
Because at -4,
Yep.
the graph changes from negative to positive.
At -4, this graph changes from negative to positive. We had a fancy word for this guy here. Mm-mm. You've got your endpoints, and then this guy over here.
Candidate.
Candidate. So, right, your candidate, I'd want to see a little bit of work. We're looking for where G prime makes that change from negative to positive, so x equals -4. Now, before we close out on this problem, still got a little bit of work to do. Your options are -5, +4, or -4. The way that you're going to figure this out, you've got to evaluate. You have to find G of -5. Where does G of -5 come from? Last class they were telling me, go look at the graph.
No.
Not going to look at the graph.
The integral.
You've got to go back. What is G?
The integral
from
from
From so this guy here is -3 to -5, f of t dt. Oh, good news. We know exactly what to do here. Right? Go find the area. You're going to have to find G of 4. You're going to find the integral from -3 to 4, f of t dt. G of -4, you're going to find the integral from -3 to -4, f of t dt. Take 2 minutes, go give me those values.
What did you say the second one was? -3 to 4.
Oh my god.
So ruling cuadrada.
So I need the area from -3 to -5, and it looks like most folks have this one already. Right, how much area is there from -3 all the way to -5?
Here.
The answer has to be 0. You've got this positive area up here, you've got this negative area up here, they perfectly cancel out. Keep going.
The harder one is the semi-circle. Yeah. Oh my god. You do the half circle and then you do the
Yeah, you need some clever geometry thinking.
First you get the
I'm hearing a lot of good conversations out there about finding this area from -3 to +4. That guy over there, I think everyone's coming up with easy. We get the 9/2, we've already got that. This triangle over here we can figure out, but hey, those two are going to cancel each other out. The big question always is, how on earth do I find those little pieces there? They're not even triangles, and I've heard from a lot of like really good sources. Marvin, what's the idea here?
find the area of the semicircle and subtract it from the rectangle.
Right, you can look at like that big rectangle and then knock out the area for the semicircle. So I'm going to have 9/2. Add on to that the area of the rectangle. It's 2 wide, it's 1 tall, so that's 2. Minus area of the circle is going to be 1/2 of pi times r squared. And I just need to know what the radius is.
I don't know.
Right, it's going to be 1 plus an area of 1/2 minus an area of 1/2 And then simplify if you want to. I think your answer is going to be 13 over 2 minus pi over 2. G of negative 4, you need to find the area from negative 3 over to negative 4. Well, that's not too bad. The area from negative 3 to negative 4 is just going to be a triangle. Area of a triangle, 1/2 base times height. So your final answer.
-1.
Uh-oh. For this last one, I need to find the area from negative 3 to negative 4.
Oh, -1. Because it's going from right to left.
If you're moving from right to left, you're moving in the wrong direction. So this guy over here has to be -1. There's always going to be a whole lot of work going on with absolute max and absolute min, but really the question boils down to, what is the absolute minimum value? Is it 0?
No.
Is it 13 over 2 minus pi over 2?
No.
Or is it -1? Okay, last class we really kind of struggled. Like the comparison between 0 and -1 was easy. But right, there was a lot of like, I'm not really sure about this guy over here. Christian, what are your thoughts about 13 over 2 minus pi over 2? Okay, but can you give me like an exact number here? Is there anything that anybody knows for sure? David, what do you know for sure?
So 13 you can just divide by 2 and then it'll be 7.
It'd be what?
Oh, sorry.
Hey, he's got a big project due tomorrow. 13 divided by 2?
Anyways,
We all
you know it's be positive and
Yep.
the other ones are negative. You have to compare against negative.
Right, but I have to know, is that number, how does that compare to 0 and -1? Jennifer, what's the key?
Well, you know that pi is close to 3, so you just
Pi is close to 3, a little bit bigger than 3, right?
you can round it down.
Sure. And
then
13 over 2 minus pi over 2, positive or negative? This has to be positive. So the final question is, what's the absolute minimum value?
-1.
Has to be -1.
Well, it's -1.
Let's pretend that says absolute minimum value. All right, good enough. We're gonna call time at that point. Okay, so tonight's homework that I'm not going to have time to check tomorrow is the first 12 multiple choice questions. We're going to focus our time tomorrow on the harder set, and that's what you're going to finish this weekend for homework. So if you guys could put everything away, we're going to start the last sticker challenge. Yeah.
I can stop recording.
Barbara's like, we're going to have nap time. No. This is sticker challenge number 4 on integration by substitution.
I can stop recording, right?
Yeah.